One final thing to mention before moving on to finding specific trig ratios of different angles is the fact that where I stop on this ray when I create my angle theta doesn't matter, right? Whether I stop here at this point that I'm calling xy, or whether I stop at this point here, which I'm calling x prime, y prime, doesn't matter because of the fact that these are similar triangles that you're forming and their sides are going to be in proportion. So whatever the ratio of the opposite to the hypotenuse in this triangle was, it's going to be the same as the ratio of the opposite to the hypotenuse in this triangle, and so on and so forth. So the point that you stop at does not make a difference. All right. And then in the next section that we cover, you'll see that specifically what we want to do is we want to stop where the radius is going to be 1, and we're going to call that the unit circle. So we'll get into that in our next section. But let's move on here to evaluating trig functions at any angle. So we already kind of touched on this a little bit. We just didn't give specific trig ratios. So we know that in the first quadrant, we had said this, all of the trig ratios are going to be positive, right? Because both x and y are positive, and r, remember, is always positive. So we would always have positive values for all the trig ratios in the first quadrant. But then if you move into the second quadrant, remember what happened is x became negative, and x over r was going to be your cosine value, right? So your cosine in the second quadrant was going to be negative. So sine and cosecant would be positive in the second quadrant, but then the other 4 trig ratios in the second quadrant would be negative because they all are going to involve the x value. And then the same thing occurs when you get into the third and fourth quadrant, right? In the third quadrant, you can see that both x and y are going to be negative. So the only one that's going to be positive are the ones that involve both x and y, because then you get a negative divided by a negative, and that's going to be tangent and cotangent. And then in the fourth quadrant, you have that x is positive and y is negative, and so on. So what you end up determining is this. So in the first quadrant, all of the trig ratios are positive. In the second quadrant, sine is positive, and since sine is positive, the reciprocal, which is cosecant, is also positive. In the third quadrant, tangent is positive because, again, it's a negative divided by a negative, so it becomes positive. And then also the cotangent is going to be positive because it's the reciprocal. And then in the fourth quadrant, cosine is going to be positive because cosine is the x value over the r value, and x is positive in the fourth quadrant. All right. And then, of course, again, the reciprocal of cosine, which is secant, is going to be positive. All right. So what happens is you usually develop this little mnemonic device that you call ASTC, right? Rotating from the first to the fourth quadrant, which you can think of as all students take calculus, right? So ASTC. That means that they're all positive in the first quadrant. In the second quadrant, sine and then cosecant, of course, are positive. In the third quadrant, tangent and cotangent are positive. And then in the fourth quadrant, cosine and secant are positive. So how can this be useful to us? Let's say we want to find the cosine of 135 degrees. All right, well, what is 135 degrees? It's in the second quadrant, right? So x is going to be a negative value. But what ends up happening is we can see from this picture here that if we look at 45 degrees and 135 degrees, they have some similarities, right? This point over here, xy, at 135 degrees, the y value is the same, and what happens is the x value is just the opposite. So this point over here at 135 degrees is actually going to be negative x, y. And if we recall, we remembered from our special triangles, right, our special 45, 45, 90 triangle, that the cosine of 45 degrees was actually the square root of 2 over 2. So what ended up happening is at 135 degrees, the only difference is that x is negative. So the cosine of 135 degrees would just be negative the square root of 2 over 2. All right. So 45 degrees and 135 degrees have actually a lot of similarities, right? X and y are the same. It's just that x is the opposite of y. and then 390 degrees, the first thing that you really want to think about with an angle like 390 degrees is that 390 degrees minus 360 degrees is 30 degrees. So 390 and 30 degrees are actually coterminal, right? Remember how we had found coterminal angles? We would either add or subtract 360 degrees. So 390 degrees and 30 degrees are coterminal. So the tangent of 390 degrees is really going to be the same as the tangent of 30 degrees, right? And then again, from our special right triangles, right, involving 30 degrees, we had that this was actually when we set up the diagrams initially with our 30, 60, 90 triangles, we called this one this um, this square root of 3 and this 2. So we would have said 1 over the square root of 3 for the tangent, but 1 over the square root of 3 if we rationalize the denominator by multiplying by radical 3 over radical 3, we end up getting square root of 3 over 3. Okay, so there's our tangent of 30 degrees, which is the same as the tangent of 390 degrees. So this whole idea of subtracting 360 or adding 360 to make the angle, you know, become between 0 and 360 is important, right? We're finding coterminal angles there. So then we have this idea of what we call the reference angle, all right? So the reference angle is actually going to be an acute angle, right? So that means, and that's an important thing to keep in mind is, so the reference angle always between 0 degrees and 90 degrees, right? That's an important thing to keep in mind. It's going to be the acute angle formed by the terminal side of theta and the x-axis. So what does that mean? That means if you have a picture like this, since we did a first and a second quadrant angle, let's say, maybe let's try a third quadrant angle, right? What if I had this angle here? That's theta. What would my reference angle be in this case? My reference angle would be the acute angle formed by the terminal side of theta and the x-axis. So in this case, my reference angle would be this angle. So this would be the thing that I'm calling theta bar, right? Theta with the little bar over it. So that's my theta bar. That's my reference angle. And then if your angle is in the fourth quadrant, let's say, if that's your theta, in this case, your theta bar is going to be that angle, right? So you're always going to the x-axis to form your reference angle. And then there's just some more examples of it, right? So in the case of, and this is where it's actually nice to think about how you would get it, right? In the first quadrant, it's easy. Theta is the same as theta bar. But in the second quadrant now, what happens? All right, well, that's your theta. That remaining angle there was your theta bar. So what's this? This is the whole 180 degrees minus what theta was. So in the second quadrant, how would you find this theta bar? You would have done 180 degrees minus, I'm sorry, not pi. You would have done 180 degrees minus theta. Now in this third quadrant, your theta bar is this little thing that's left over here, right? So this was the whole angle minus 180 degrees. So in this case, your theta bar would have been the whole angle, theta, minus 180 degrees, right? And this is your theta bar. And then in the fourth quadrant, well, this theta bar here is going to be the whole 360 minus theta. So in this case, in the fourth quadrant, theta bar is going to be 360 degrees minus theta. So what's the reference angle for 5 pi over 3? Well, 5 pi over 3 we could see is in the fourth quadrant from this picture. So what we just did is we recalled that the reference angle for the fourth quadrant angle, how would we get it? We would do the whole thing, the whole circle, which is 360 or 2 pi, and we would subtract out theta, right? So it's going to be 2 pi minus 5 pi over 3, which is going to be 6 pi over 3 minus 5 pi over 3, right? We're just getting a common denominator. So the reference angle here is going to be pi over 3. Right. And again, why did I use 2 pi instead of 360? Because I was dealing with radian measure and not degree measure. All right. And then for 870 degrees, the thing you got to realize is, well, 870 degrees is really wrap around once. That's 360. Wrap around again. That's 720. And then you need another 150. So that's actually your 870 degrees, right? You've wrapped 2 full times around the circle and then almost another whole half time. So what you had to do is you had to subtract out that 720 degrees and you end up with 150 degrees, right? So you're basically just turning it into that angle there, right? Because you're saying that it's coterminal with 150 degrees. So once we have 150 degrees, we've established that it's in the second quadrant. What we would then do is we would just say, all right, well, in our second quadrant, how did we find the theta bar? Remember what we said with the second quadrant, we would actually do 180 minus theta, which is 150, and we would get 30 degrees. All right, so our reference angle for that is 30 degrees.